Hello everyone, welcome to FEMSA Medu Consultancy channel. Today we'll be looking at a question on binomial expansion, and we'll try to put solution to that question together. Here I want to first believe that you have a bit of knowledge about binomial expansion. We just want to solve a question together. So the question says, obtain the first four terms in the expansion of cube root of 1 plus x. There are four different options. So solution. You need to recall from binomial expansion that 1 plus x all raised to power n is the same thing as 1 plus n combination 1x plus n combination 2x squared plus n combination 3x cubed plus n combination 4x raised to power 4, and it continues like that until it gets to n combination n x raised to power n. But since the question says we should obtain the first four terms in the expansion, then we just need to count the first four terms of our binomial expansion. The first term is 1, second term is n combination 1x, the third term rather is n combination 2x squared, and the fourth term is n combination 3s cubed. So we can ignore the other terms. Now from here, our n combination 1 is same thing as n combination 2 replace as this, n combination 3 replace as this coefficients. Then maybe for better understanding notation, we do know that n factorial is the product of all positive integer numbers from 1 up to n itself. So, or you can simply say is the product of all positive integers less than or equal to n. So this is what it means, this expression for n factorial. Then n minus 1 factorial is simply following the same pattern. That's the product of all positive integers from 1 up to n minus 1. And this will also terminate. Then from here, from the 2, we can imply that n factorial is the same thing as n times n minus 1 factorial. So for example, 4 factorial will be 4 multiplied by 3 multiplied by 2 multiplied by 1, and 5 factorial will be 5 multiplied by 4 by 3 by 2 by 1. But if we do not want to get to 1, we can terminate it at 4 but simply put factorial. That's just the application of this equation here. Don't forget that 0 factorial is 1. Now n combination r is the same thing as n factorial over n minus r factorial, then r factorial. So from here, from this equation or from this formula for combination, we can deduce that n combination 1 is going to be n factorial divided by the product of n minus 1 factorial and 1 factorial. Now we can rewrite our n factorial as n times open bracket n minus 1 factorial divided by this denominator, and from the observation of what is obtainable at the numerator and the denominator, we see that n minus 1 factorial is a common factor. So it will divide each other and will be left with n divided by 1, which will be n. Now for n combination 2, which will be the same thing as n factorial divided by the product of n minus 2 factorial and 2 factorial. And by the time we also rewrite n factorial, we will have n multiplied by n minus 1 multiplied by n minus 2. Since we are stopping there, we indicate factorial notation at that point. So we can also see that both the numerator and denominator has a common factor of n minus 2 factorial, and that will also cancel out. We'll be left with n multiplied by n minus 1 divided by 2 multiplied by 1. You can decide to leave it this way, or you can still rewrite it as n into n minus 1 divided by 2 factorial. Now n combination 3 is the same thing as n factorial divided by the product of n minus 3 factorial 3 factorial. And by the time you also expand this in the same manner we've done for the other two, we'll have this expression. Then you'll notice that both the numerator and the denominator has a common factor of n minus 3 factorial, n minus 3 factorial, and both will cancel out. We'll be left with n into bracket n minus 1 into bracket n minus 2 divided by 3 factorial. If you so wish, you can decide to evaluate 3 factorial and that will give us 6. So let's go back to our solution. So at least you now have an idea of how I replaced n combination 1, the coefficient of x, x squared and s cubed with what we have in the next equation. So let's now apply that to our question. Cube root of 1 plus x, from index notation, we can rewrite it as 1 plus x all raised to power 1 over 3. Okay? So now what we'll just do is that by the time we compare 1 plus x all raised to power 1 over 3 to 1 plus x raised to power n, we can simply say that they are the same on the basis of just replacing n with 1 over 3 in this expression, or the expansion of 1 plus x raised to power n. So which means that 1 plus x all raised to power 1 over 3 is the same thing as 1 plus 1 over 3x plus 1 over 3 into brackets 1 over 3 minus 1 divided by 2 factorial x squared plus 1 over 3 into brackets 1 over 3 minus 1 close bracket open another bracket 1 over 3 minus 2 all divided by 3 factorial s cubed plus dot dot dot. The series continues. You just realize that I only just replaced n with 1 over 3 above here, and that's what is giving me what I have here. Now if I decide to evaluate this coefficient, I'll be left here with 1 over 3. Here I will have 1 over 3 multiplied by minus 2 over 3. Here I will have 1 over 3 multiplied by minus 2 over 3 multiplied by minus 5 over 3. Now the evaluation of this will give me, the numerator will give me minus 2 over 9. Then this denominator can be written as 1 over 2 multiplied by 1 over 2. Then I have x squared. The entire numerator here, 1 over 3 times minus 2 over 3 times minus 5 over 3 will give me 10 over 27. Okay. Then this denominator can be written as the product of 1 over 6. Then I have s cubed. Then I still have the term still continue, but I just need the first 4 terms. So I have 1 plus x over 3. Then by the time you consider the evaluation of this, these two can actually terminate these two. I'll be left with minus 1 over 9 s squared. By the time you use that to multiply this plus, I will have minus x squared over 9. Then here 2 is common. 2 is a common factor. 2 divide 6, I'll be left with 3. Then 2 divide 10, I'll have 5. Now at the numerator, I'm going to have 5. That shows that here there's meant to be 3. Okay, so I'll have 5 multiplied by 1. I have 5 left. Then at the denominator, there's 3 here. 3 multiplied by 27 is 81. So the simplification of this will give me 5s cubed over 81. So there are just 4 terms here. So this is our final expression for cube root of 1 plus x. You can take this practice question and ensure you state your answer in the comment section below. If you like this video and one way or the other you've learned something from it, feel free to like it, share it, and subscribe to this channel. Thank you. God bless you.